I would really like to make wastewater-based surveillance an accepted tool that is widely applied. We observe pharmaceutical consumption at the community level, and then we try to find explanations why they use this. Just comparing concentrations doesn't make sense. Just comparing absolute loads doesn't make much sense. Whenever a new variant was discovered somewhere in the world, everyone wanted to know, is it already in Switzerland? Everyone has their part, everyone has their strengths, and as long as there is mutual respect and acknowledging everyone's expertise, this works very great.
That is Christoph Ort, head of the Urban Water Maangement Department at the Swiss Federal Institute of Aquatic Science and Technology, ERWA. Christoph's mission of understanding the dynamics of pollutants in sewer systems and close relationship with environmental chemistry and microbiology has shaped his interdisciplinary work that is actively supporting public health. He is well known for his work in wastewater-based surveillance, where he searches the sewer network for illicit drugs, pathogens, pharmaceuticals, and other biomarkers to complement and better our understanding of their spatial and temporal trends. My name is Peter Markus Bach, and this is the Grand Challenges Podcast, a show about inspiring individuals who are stepping up to tackle the global challenges that our world is facing in their own unique ways. We reflect on the many out-of-the-box ways our guests have navigated the complexity and intricacies of the environment at the cutting edges of science, engineering, technology, and design. On today's show, Christoph and I go in-depth on wastewater-based surveillance, including related fields of sewer sociology and wastewater-based epidemiology. We discuss terminology, process, interesting insights from major studies that Christoph was part of, and how crucial the interdisciplinary collaboration was, especially in supporting communities with valuable data during the COVID pandemic. Detailed information is provided in the show notes over at petermbach.com/podcast. Thank you for joining us today, and please enjoy the show. Christoph, welcome to the show.
Hello, Peter.
I am so glad that we can finally do this because some of the stuff you do has really intrigued me over the last few years, and I'm really excited to get into that.
It's very good because we don't know the word procrastinating in German, but I felt like that I did.
Are you sure you don't? Because on your desk, I saw this awesome little note block, and it's called a to-do list, but it's spelled T-U-D-U, as you would pronounce it in German.
Yes. Yeah, you're right. And you saw it was empty, right?
Yes, and the word procrastination was on there. But apparently it was in denial of procrastination.
Yes, correct.
But nevertheless, it's good to have you here. And we've actually, in preparation for this show, decided to bring some props with today because, we need to be a bit more physical and interactive given the summer weather outside. Keep ourselves, cool and moving.
To be precise, you decided, right?
Oh, yes, I guess that's true. But I thought, in relation to what you showed me in preparation, I felt, why not do something different? We always try to innovate on a daily basis.
Yes.
Maybe perhaps the first prop is actually a t-shirt I'm wearing. We'll put a picture in the show notes. But for those who are curious, it's got a little sketch of the front part of a bicycle, or the handlebars and part of the wheel. And the message on it is, enjoy the ride. And I saw this t-shirt actually while I was in Romania, in one of these normal brands you can find everywhere else too. But I really liked the message. I felt it's also a very strong message on this show, that it's about the journey. But in your case, you love bike riding, and you actually told me you also remember a particular t-shirt that you had. Could you tell me about that?
The slogan that was written on that t-shirt was, define your life, ride a bike. And recently, when thinking about myself, when I'm most happy, I realized that when I ride a bike, then I'm really happy. That I'm happy no matter where I ride my bike, to why I ride my bike, to it's just being independent and being happy that you don't have to walk and make each step, but you can also just roll some distance sort of for free. Although nothing's for free, you also have to go up and pedal against the resistance, the wind or meters of elevation gain.
Very strong messages. Always associated with bikes. I've certainly picked up bike riding again with the, ushering of warmer weathers in the last few months. So it's been good to experience that rolling rather than the walking. Mm-hmm. Yeah, bike riding has been very important to you. And I think, in fact, Lena Mutzner, who was on the show before, just a few episodes ago, in episode 45, she actually did not mention a particular inside joke that both of you shared. You supervised a PhD, but there's always this one joke that you will always remind her of from time to time.
Yeah, it's taking the piss out of the people, right? Because she said that she's got a new full suspension mountain bike with 100 centimeters of front suspension. I said, if you continue with units like this, then you probably won't get your PhD.
Look at the common units problems. But I guess she must regret ever having said that. I'm sure she wanted to show off her fancy bike because she's one of these bike riding fans too.
I think in the meantime, she sold it, and we were also riding our bikes together when she was on tour with her child and her partner over the Swiss Alps. That was very impressive, and I accompanied her on one stretch.
No, that's lovely. I have yet to go for the more hillier parts. I'm still on flat surfaces, but I'll get some tips from you when I get that far. Bit more gym for me. Mm-hmm. The other prop we have with us today, and I had to go down into my cellar digging for it, but I managed to find it. And that's, one second, I get it here, our PhD thesis. And the reason I brought it is because when you showed me your PhD thesis, and so these are, I guess, the ones you would send off to the examiners, they would examine them. I think nowadays, in many modern universities, they like to print fancy booklets, mini booklets. But during our time, we had, nice bound A4 style printed thesis. But what's interesting about yours, so mine has got this weird hardcover, fancy embroidery, Australian unis, but yours is, and I measured this with a ruler, is 0.5 centimeter, whereas mine is about 1.5 centimeters thick.
Or even more.
Or even more.
That's 2, and mine is, yeah.
Let me get my trusty ruler. It's 2.5. Geez. So, yeah. And from page numbers, we're comparing.
Mine is 8 millimeters.
Geez. We're comparing from page numbers in terms of how much we wrote to get our PhDs examined. I have about 300, and I'm going to just include the appendix because sometimes you need supplementary material. Yeah, I'm at 313 pages.
And I have 79, including my short CV.
So, very interesting thought about how long is a thesis? And I think many PhD students always ask that question. And after seeing yours, I just have to ask, what is the story behind, I guess, your decision to finish the thesis in 70, how many pages?
79. I think our PhD father at that time, it was just about the switch from writing a monograph to writing papers and submitting a series of publications. In my case, 4, 3 first author and 1 co-author.
Very impressive.
And he said, I don't like these hundreds of pages long theses. And it's just like you have to sort of reduce to the essence and just give me the gist, etc. And then I submitted this one and he said, oh, did you have to print on thick paper, one-sided, so it looks like something? And I was really offended. And he also used the term like, looks like an SIV-Heftli.
So it's like a little booklet you can take with you.
A5 for primary school students, pupils who read this over their holidays or whenever, in addition to what they learn in school.
Like a summer novella.
Yeah, that was it really offended me. But then on the other hand, I also thought, well, I mean, if 80 pages are not enough, but more than 100 is too much, well, where do I want to be? Do I need to be at 95 or 85 or whatever?
And that's really a question nowadays as well. I mean, people's attention spans have become so short, and yet we still want these long PhD theses. And admittedly, with this idea of a paper thesis, now people are just slotting journal papers in. Isn't it just sufficient to just staple all the journal papers together? And I think it's a very interesting evolution of how we communicate science as well. But I thought it's a nice springboard into getting into your story. Mm-hmm. And so you actually studied cultural engineering or Kulturingenieurwesen in German. What is that? Could you explain that to me? Is that like an old form of kind of engineering?
It was, when I remember correctly, one of the oldest studies at ETH to make the land habitable and to develop the land.
Okay.
And it's been a broad mixture of civil engineering, road planning, urban planning, but also wastewater treatment, urban water management, surveillance, either terrestrial or satellite surveillance, etc., all this. And in the meantime, this as a name doesn't exist anymore. It underwent several restructuring, so it was still Abteilung 8 at that time, and now it's together Bau, Umwelt und Geomatik.
So, yeah.
And it's more the environmental engineering side that I studied at that time.
Okay. Yeah, I guess it's sort of evolved over the years because I guess the surveying or the remote sensing sort of started to split from it, geomatics as they call it at ETH as well. And environmental engineering, I guess, with the world changing and facing so many challenges, I guess there's just more things to learn as well over time.
Within each individual discipline, that's
Exactly.
correct, yes.
But nevertheless, you finished in 1999 and then decided to venture further into the world of research. What motivated you to go into environmental engineering, culture engineering, and in particular sewer systems, where you're now really doing a lot of your work?
That was probably more of a coincidence because back before I chose my studies, I just didn't want to end up in a big company, just being a small cogwheel, but I wanted to have impact and because I care for the environment. And yeah, that's how I got into this. It's also been, I didn't initially want to do a PhD. I was involved in a small project for web-based learning in urban drainage.
Yeah.
Then I got in touch with this good crowd of people who did PhDs at EAWAG in the context of urban water management and wastewater treatment. And I thought, it would be great. I mean, I think I would just be also liking to pursue a PhD because they seem to have been happy and pursue their thing and do this and investigate and find new things. And then I was really, really happy that when my PhD father offered me this position that I could do something.
Yeah, that's lovely. And I guess, you see the chance to do a topic that you're really interested in, I guess, semi-unobstructed. Maybe at first glance, it feels like completely unobstructed for 3 years. And then, having fun with your colleagues and really discovering something new and making a difference in the world. I guess that's the pretty picture, right?
We were actually 3 people who were more or less at the same time offered a PhD because our PhD father was towards the end of his career. And I think he just told us, do something in urban drainage with uncertainty so that everyone gets their profile and deserves a PhD in the end. But try to collaborate, but also try to be individual. And the topic was totally open.
Okay.
It's not like an EU project where today you already have this is the deliverable, that's the deliverable. And I have to admit, I really suffered, whereas my 2 colleagues, they really enjoyed this first year of finding a topic and finding methods and digging in everything and reading everything. I really suffered to try this. I couldn't really cope with this sort of too many degrees of freedom.
Oh.
But in the end, all the 3 of us managed in their ways to get their PhD.
And in the end, you worked on sampling of micropollutants, trying to understand the dynamics of micropollutants in sewers. And I guess it's really the dynamics of sewers themselves. Tell me, how did you get to that point?
I think it was also another coincidence because the environmental chemists, they just started to analyze micropollutants and also not only in environmental samples or drinking water, but also in dirty matrices as wastewater. And so they said you could use maybe the benzotriazole, which was at that time only known to be in dishwasher detergents, also in de-icing liquids on airports, but not enter typically in a wastewater treatment plant in municipal wastewater. And so maybe you could do something with this. I initially had no clue what to do. And then I thought, well, maybe when I read how people take samples, they take a grab sample or they take a sample every hour to make a composite sample. I thought, if they don't know what the dynamics of an individual substance is, how do they know how reliable, how representative their composite sample is? And so I started using this benzotriazole from dishwashers to make a very simple model on what the dynamics is that we would expect. And that in the end worked out really well as a basis to have more insight into sampling and proper sampling.
And I guess there was a very nice quote that you quoted from the US EPA in one of your papers. And this sort of also harks back to the episode with Lena Mutzner, where she gave us a very nice overview of how you go about getting water quality data. And we discussed a lot about the space and time variations, and we'll get to that in the context of benzotriazoles in a minute. But this quote I felt was really nice and sort of resonates a lot of how you focus on trying to get good quality data. And that is the 4 basic factors which affect the quality of environmental data are sample collection, sample preservation, analysis, and recording. Improper action in any one area may result in poor data from which poor judgments are certain. And I think especially with this increasing list of different pollutants, chemicals, microorganisms, and all sorts of other nasties in our waterways, as you said, understanding the dynamics is incredibly important.
Yes, that's correct. And I was also very proud of this, that I could show this, because it's a lot of effort. Because initially, or for the research questions we tackle, we often may not be interested in the dynamics, although this would help us learn more about the processes driving these dynamics behind it, and maybe also processes, how things work. But then for the composite sample, you need to know so that you're not missing out the peaks or other dynamics, that you have a representative sample. And so I think on the practical side, many cantons or regulatory bodies And engineering companies, I think they are more aware of that they need to do a good job also related to taking the sample. Whereas scientists who develop the analytical methods, they may not care initially that much about the sampling or simply not be aware of what the dynamics is. And so this was my luxury that I had time to dig into and just expand knowledge in the domain of dynamics of pollutant fluxes in sewers, which served for many as an eye-opener. And they now also often cite my paper.
Yeah.
Because I was criticized for this paper, that the title is a little bit too, what would you call this? A little bit too...
Provocative?
Provocative, maybe. Yeah, that's a neutral formulation of what in German would have been used. But anyway, yeah.
I don't even want to know what possible words you might have received. But I feel like, we need to be critical and provocative at times. Otherwise, people don't read it. But I guess the title of that paper was really about sampling for pharmaceuticals and personal care products and illicit drugs in wastewater systems, foreshadowing listeners about things we may cover on this show. But the key part of the title, are your conclusions valid? A critical review.
Yes, correct.
In a way that allowed you to then really come up with what should be good practice sampling, because to capture the dynamics truly of different kinds of chemicals, you need to be able to understand how they appear. Let's use the example of the benzotriazoles again. So you mentioned dishwasher tablets as well as de-icing for airplanes, which de-icing usually happens in the winter when the airplanes are just about to take off. I remember that sitting in some of these airplanes myself, and they said, we're about to leave, but we just need to spray the plane. So certain sort of spikes or pulses in when that actually gets applied and then runs off into the sewer system. Dishwashers, we're not washing our dishes, 24/7. And I think different people have different preferences. So for a chemical like that, describe to me, how would you get a good picture of it in your sewer system? Like, what are the frequencies? How would you know where to sample? And I guess what's important to know about this particular chemical? Is it the amounts it's coming at, or is it certain time frames?
Well, that really depends on your research question, what you're interested in, because once it enters a wastewater treatment plant, go through a primary clarifier, you have certain attenuation, and then you may just see the diurnal variation, but not the short-term variation. Mm-hmm. But when you have a combined sewer overflow, where in minutes water can be discharged to the environment, it may really matter whether this water is discharged into a creek of not yet increasing flow, because the surface runoff from urbanized areas is much quicker than the creek. And then you might have periods where there is no dishwashing and you may not have a peak, but maybe someone's just rinsed dishes or run the dishwasher and the dishwasher empties, and then you have a peak that is straight away also discharged to the environment. And so my first sampling campaign that I did was 30-second interval.
Oh, wow.
Then I realized, that's maybe a little bit too much, but I didn't want to miss anything. And so then next time I went to 2 minutes, and that's about the order of magnitude when you want to go for an individual toilet flush, an individual shower, or an individual dishwasher, or whatever other appliance in the household that discharges into your sewer system, and you're close to source where many of the combined sewer overflows are located. If you want to be on the safe side, then you should go somewhere around the minute scale, 1, 2, 3 minutes, to not miss any of these pulses.
Which is much more finer scale than what has traditionally been done in the area.
And even if you're only interested in the average that discharges over this time, to not miss any of these peaks, you should just really use something on the minute, and ideally volume proportional or flow weighted, so that you get proper loads.
So really understanding the dynamics of the quantity before you can go in and say, all right, if we know these are the best times to then get the quality data, then you're much more strategic about getting the pulses that you need to see.
Well, maybe it's not about the pulses depending on the application, but it's about to have the time frame covered properly.
Yeah. Just out of curiosity, so what do benzotriazoles do for the dishwasher? Is it for cleaning or?
I think the industries, they actually want to replace it because it's only small amounts that are in these tablets. But they didn't find any replacement that leads to the same good result of dishwashing. It's an anti-corrosive, so I assume it's also protecting the dishwasher itself, but it's also formerly used to have good results for silver cutlery, though not many people use these days, or don't have it at all, or they wash it by hand.
Having shiny cutlery on the table, I guess, for when you have guests over. No, very interesting. And I guess it's just one chemical of a whole suite of things you've monitored throughout your career to date. And I think more importantly, as a topic that you've done quite a lot of work in particular in also supporting Switzerland and a lot of European countries as well. And that is a topic we've actually never covered on the show before. And it goes by the name of wastewater-based epidemiology.
Or wastewater-based surveillance, because that was also a development. It started off with sewer sociology, which was just mostly about wastewater amounts or wastewater flows, where you see through the temporal pattern over a day, where you can see irregularities. For example, when Madonna comes on stage, when she gives a concert in San Diego, or when some bushfires hit some villages where people just briefly go to the loo, but then there is no wastewater flowing anymore because they had to flee.
Interesting. And you're using the bushfire example because actually just after your PhD and a short postdoc, you also spent some time in Australia, in Brisbane, as I understand.
Yes.
And we do have connections to someone who's been on the show before, namely Anna Deletic. And I think, I've met you for the first time through Anna, in fact. Mm-hmm. And I think then 2 years later, you were back in Switzerland and it's like you disappeared overnight.
Yes, I did.
And Australia was also a place where you got to get more exposure to this whole epidemiological side. And I guess we'll get into terminology shortly.
Yes.
Because you were looking at hospital wastewater in particular. And there comes up the term that I'm sure will be a very relevant keyword here, which is namely biomarkers, which is what you try to search for in the wastewater when doing this kind of work. But I love a good terminology discussion. So tell me a bit about the history of wastewater-based epidemiology, surveillance, sewer sociology, and how did these terms evolve? Then I guess, do you have a preferred term? Is there general arguments about what to use in the scientific community?
I think, as I said, sewer sociology, I think that originates from the US, from a private company who measured water quantity or flows in sewers, and then just discovered that you find some irregularities and you can explain them with obvious or maybe not so obvious.
So I was linking the social behavior to what you observe.
Yes.
And as you mentioned, Madonna on stage, I know that in Australia, I've seen a graph once from Melbourne Water. They put up a graph during the Australian rules football finals and how many people were using the toilets in between the breaks.
Yes. Yeah. There is, like, if you check this out, there is tons of examples. And then when people started doing illicit drugs, analysis of illicit drugs to estimate consumption at the community level, more objectively, they used the term sewer epidemiology.
Okay.
Which then obviously more native speaking people said it's not about the epidemiology of sewers, it's about wastewater-based epidemiology. And then it's turned into, now with the biomarkers, into wastewater-based surveillance. Because initially not on the chemical side, where I just explained this terminology development now, it was also done before COVID, which was in the microbiology part more called environmental surveillance.
So lots of different terms, but I guess the transition from first sociology, so relating the social aspects, to the more health-related, so epidemiological. I looked up a definition of epidemiology. Just to be precise here, it's the study of the distribution and determinants of health-related states or events in specified populations. I guess that's why people started to use that. To what you would call now surveillance, because it's really trying to, understand in space and time what is happening, maybe not necessarily for the health perspective, but...
And many people have done wastewater-based monitoring for various research questions or for various aspects in the past, but they just didn't name it wastewater-based epidemiology or wastewater-based surveillance.
Yeah.
But I think it's nice if you have one term that now is more or less neutrally accepted in all disciplines.
And your journey in that began with illicit drugs. And you were actually part of quite a bigger consortium as well. There have been some papers that came out, we'll put them in the show notes, quite fascinating stuff, where you really looked at a whole spread of cities across Europe. This was around 2012, 2013 when you did the study. What kinds of drugs did you look for?
Well, I have to admit that me personally, as an environmental engineer, I'm not so interested in a specific substance, but because that's the expertise of other people, drug and prevention experts. And I just help these people to make good or to have good knowledge about the dynamics of these, understand the sewer system better, also about how many people reside within a sewer catchment or contribute to a given wastewater sample, so that we know how we can better normalize this in terms of when you compare small and big cities, because just comparing concentrations doesn't make sense. Just comparing absolute loads doesn't make much sense. So it's about these population normalized daily loads that we use now, both in the chemical and the microbiology part.
Yeah, I guess bringing the practical lens to it, I guess, what does it mean? Because anyone can look for a particular concentration of something, but to then make sense of it also from the infrastructure perspective, given you have kilometers of sewer systems throughout an entire city.
Yeah, that's a big part of my research as well, to understand better these in-sewer processes, or what happens during in-sewer transport, from flushing the toilet to recovering or trying to get the signal, as we spoke about before, the sampling, but also with regard to stability and processes, degradation and other losses.
Yeah. And so common drugs include that you looked for?
Cocaine, benzylacanine, which is a human metabolite after the consumption of cocaine. Yeah. So not cocaine itself, because it could be thrown down the toilet or in sewers during seizures. Methamphetamine, amphetamine, MDMA, the ecstasy. Yeah. But I mean, the list is long, and it's since now wastewater-based epidemiology also has reached more, I would say, acceptance when we saw during COVID, because the populations, the countries did so much surveillance on the case side, where we had the opportunity to validate the findings in wastewater with a lot of effort for cases. Because before it was like, how do you know that this matches with consumption? Yeah. And just science alone would not have had the resources to make this sort of big calibration experiment.
True. And it comes down back to that key word, the biomarkers. You mentioned the example with cocaine. It's looking for the metabolized results or the outputs from the biological activity, and not for the actual substance itself.
Sometimes there is no other way than looking at the parent, but there are methods to look at metabolites or chirality, for example, particularly in the case of MDMA, whether it was consumed or not consumed.
And in this particular case, that also applies to many other conventional drugs that we're used to, like caffeine, alcohol. But then especially in the case or during the period of the pandemic, which I'd be curious to hear your story shortly once we've covered some of the basics, also SARS-CoV-2. And I guess the methodology is also quite fascinating, because you're really looking for these biomarkers. And I guess, for listeners to get a better understanding, if you imagine a wastewater sample has all sorts of nasties, but there are methods, liquid chromatography and mass spectrometry. You can go look it up to see what they do. But
this is on the chemical side, yes?
It's on the chemical side, and that's how you can figure out whether the particular substance you're looking for is in your sample or not.
I think it's really fascinating, because you have these hundreds of thousands of cubic meters of wastewater. Then the important first step is the sampling, which gives you 10 to 20 liters, which is representative for these 100,000 of cubic meters. Well taken and well mixed. And we get a subsample, an aliquot of this, maybe a liter, or in the end, we just use a couple of 100 microliters without any sample preparation for this high resolution mass spec, direct injection. Obviously not with the low limits of quantification, but then to get a broad spectrum, or as broad as possible spectrum of many substances. This is fascinating. And the same on the microbiology side. There we have to do a lot of extraction and purification to increase the concentrations to be detected quantitatively appropriately.
And I guess you have to think of this in space and time as well, because it's not just about, getting one sample, but to understand consumption trends or, spread of the virus during the pandemic, or I don't know how many people drink coffee generally. You need to plan that out quite extensively.
Yes, that's true.
So the paper that really studied 19 European cities, and you were part of quite extensively, actually found some very interesting trends at the end of the day about how different illicit drugs sort of were used across different cities. And they found, for example, that cocaine was higher in Western and Central Europe, less in the North and East. But apparently you had other drugs like methamphetamines in more the northern parts. Particularly you looked at Helsinki and Turku in Finland, or in Oslo as well. And then you had also temporal trends like cocaine and ecstasy being elevated during the weekends, which kind of makes sense. You can sort of figure it out based on people's potential behaviors. But nevertheless, with such interesting results from the study. I mean, how can these kinds of findings and methodologies then be used in practice? I believe you've also been interviewed by news outlets. You've been talking also to law enforcement. What were some of the outcomes from a lot of that work?
As I said initially, I'm personally not so much interested in substance X or Y. And maybe some of these findings for drug and prevention experts, they were not so novel. But if you had asked them, how much is it, how much more is used in city A or city B or country M and N, I think no one could have really put numbers on it.
Yeah.
And I think to have this objective way, this non-biased way of at the community level, obviously it's not at the individual level, this is clear. And that's why I also think it's not instead of surveillance at the individual level or knowing from individuals how they consume, what they consume, etc. It's complementary. It's a complementary tool to give you amounts, and then have models on how to describe how individuals contribute to this total load that we observe in sewers, because we don't know whether this is being consumed by a few individuals or hundreds of individuals. And then together with experts from different fields, this is why it's so fascinating, because it's such an transdisciplinary field, to use this data and these simple models to realize where knowledge gaps are or where we agree on how things work and why things are the way they are as we see it on these maps. And obviously these maps, they are ein gefundenes Fressen for journalists, because they will just say city X is leading Europe's ranking with regard to cocaine consumption or whatever.
Yeah, the clickbait, as you mentioned in German.
And we didn't analyze all cities, because maybe there is even cities that have higher consumptions than the ones that we analyzed.
But I guess studies like this aren't exactly cheap to do either, especially large research consortia. So, I mean, that's already incredible with what you were able to produce.
And it's growing, this network and the cities that contribute year by year. And I think many of the cities or countries also lost a little bit the fear of that this is done for sensationalism, because we've seen that this probably has no negative consequences on whether this is going to be experiencing less tourists because of knowing that they consume more or less of whatever substance.
Yeah.
And I think it's just become more and more accepted that this is a tool that provides valuable information, and it's not so expensive. So I think many cities and countries nowadays invest into this.
And it's really demonstrating the value of a very objective kind of source of measurement that can be used to corroborate with other kinds of data. I mean, typically drug use is more questionnaire-based. And I guess, whatever law enforcement or other stakeholders in the whole decision process sort of have as far as research or information is concerned. And it just highlights again the interdisciplinary aspect of it and how much more, I guess, gain you can get from working across the disciplines. But on a more, I guess, urgent case was the pandemic itself, that a lot of these techniques also apply to looking for viruses, microorganisms, pathogens, disease vectors. And you had a pretty strong active role with that during the pandemic. Tell me about the story during the pandemic and how you got there.
Let me start before the pandemic, way before the pandemic.
Way before
the pandemic. A friend of mine, Jörg Rickermann, he said we should look for diseases, not only for chemicals. And both him and myself, we tried to convince microbiologists to do wastewater-based epidemiology, and everyone sort of dismissed and said, no interest. Well, sounds good, but too many other things to do. And so, because we are not the microbiologists, we are not the chemists, we don't drive this. We have to partner up with microbiologists or chemists to do these studies.
I guess because you can understand the spatial aspect, the flows and the infrastructure, but you need the analytical side of it to come in, depending on what you're looking at.
Yes. And this is the fascinating thing, right? You need to know the dynamics, you need to know the system, you need to know everything behind, but you also need to have the analytics. This is your quote before. If you fail in one aspect, you will not have good data at the end.
Indeed.
And so like in 2020, I was on skiing holidays. I remember exactly one of my colleagues, Tim Julian, a microbiologist who I wanted to convince before to do wastewater-based epidemiology with pathogens or with microorganisms. He sent me an email, and I thought initially I'm not opening it because it's holidays. And And then I still opened it a day or two later, and he was asking whether I still have some sampling ongoing because he's thinking a little bit about this pandemic and maybe we can find SARS-CoV-2 in the wastewater.
And this was around, was it January, February? COVID had just reached Switzerland,
yeah,
right?
Just short before it had reached Switzerland. Yeah. I think he wrote the email when the first case was known. And so I thought, finally I got someone who is interested in doing wastewater-based epidemiology and microbiology. And since we never succeeded before, probably we're going to be the only ones in the world doing this. But, everyone else did it. But it was good. Within 2 days, with Tamar Kohn from EPFL, the three of us, we have decided to do this. And it didn't take long until Swiss television was knocking on the door and asking whether we can do this. And they started already filming before we even had a method in place. And then within a month, we succeeded to have the first detect and quantification together with EPFL, and that they could broadcast this news on their popular science show.
Yeah. And with this method and I guess monitoring in place, you work together with the Department of Health to then really try and understand what the levels were in the wastewater and corroborating that with the reported case numbers on a daily basis practically.
Yes, with the Federal Office of Public Health, we had very successful collaboration.
Yeah, and it went on for practically throughout the whole pandemic. I guess also post-pandemic, you were still doing a bit of it.
Yes, sure. No, this is really great that we have the support and the interest from the public health side to also look at other pathogens and not to let die the monitoring or the surveillance in wastewater just because the pandemic is over, because the next pandemic will be approaching at some point.
But I guess in the case of COVID, if we think about it, it's been a few years now since the pandemic hit. But yeah, from the first lockdown until, they released the restrictions, and then really for another year and a bit, it dragged on. I guess knowing this, or having this information ahead of time would also have implicated a lot of lives saved during the whole pandemic itself, right?
That's interesting that you say this life saved. I don't have any estimate how many lives this saved. And I don't know. But on the other hand, maybe I put it in a different perspective. Whenever our data was delayed for some reason, maybe for quality assurance, quality control reasons, because we always want to have reliable, trustworthy data. Yeah. We did very rigorous quality control. When our data was delayed, it didn't take long until the vulnerable groups, vulnerable individuals contacted us asking whether we stop the monitoring because they look at it daily. They use this as a personal risk assessment tool to decide whether they should go and work in their workplace or do home office, whether they meet friends at home or go out for dinner or whatsoever. So this was very rewarding. A little bit sad that you don't hear you're doing a good job whenever it works. Only when it doesn't really work, then you see that the people rely on it.
But it's nice to see that you don't hear it, but people still, they come to you, and eventually you do see how much it does help the populace. And I guess, Department of Health definitely got a lot of support there, because I think the numbers were one thing, but it was very hard to understand how this virus was developing and changing over time as well. And in particular, the spatial patterns, because, people, I think as soon as they were allowed to move, and Switzerland was one of those countries where lockdowns released very early, I think having that dynamic data, I think really, it just improved quality of life in general, because we could do more preventative management or reactive, very quick management.
Because many didn't know whether it was a normal flu or cold, or it was COVID, or it was a new variant or not. Whenever a new variant was discovered somewhere in the world, everyone wanted to know, is it already in Switzerland? How many? Is it increasing more quickly? Is it maybe more severe? Whereas for severity, we cannot say anything from the wastewater, right? We just observe quantities excreted. But the dynamics, because it didn't follow this typical pattern of succession as it is for influenza A and B or RSV or other diseases, pathogens that spread during typically winter. Whenever there was a new variant, there was an increase and there was a wave. No matter if it was summer or spring or fall or whether it was holidays or not, it's just like been totally different. And also with the new variants, that there was a group around Nico Behrenwinkel at ETH Zurich that managed to find out how to determine the quantities of new variants coming up and calculating growth advantage and how long it will take until we overtake other variants that were predominant before. That was really very valuable.
It's incredible how much you can learn just from really doing this kind of sampling and analysis. And as you say, it's really a combination of understanding the big picture, the infrastructure, the flows, and also the analytics behind it.
And also, unfortunately for now, we cannot identify new variants in the wastewater because of this big mix. Only known variants from clinical cases, but we are working on it, or they are working on methods that also allow de novo identification of new variants in wastewater.
Along with many of the other pathogens you mentioned, influenza strains, or even, I guess, other kinds of nasties, and hopefully with plenty of notice so that we can take any kind of preventative actions as well. In a way, this also highlights again how often you should be sampling, how rigorous the sampling is and how important it is. And one very nice piece of technology you developed as well throughout the years is this so-called MS2 field. We've mentioned it before on the show, actually, all the way back in episode 10 with Daniele La Cecilia, who I think used it in one of his works. But you're, in a way, one of the masterminds behind MS2 field, or the mastermind. Tell me about it.
Yeah, together with Heinz Singer and Michele Strauss, who was a postdoc at that time, we dreamt of, instead of collecting samples, and particularly if you want to know the dynamics, to go out and take manual samples, grab samples every 2 minutes, every 5, every whatever. Just have this high-resolution mass spectrometer in a trailer that actually we can transport into the field, and that it measures automated and sends the results, a preliminary quantification of results onto your mobile phone, so you see how it works, you see what the dynamics are, and this was really an eye-opener and it was a game changer.
So it's this little box, this container with the measurement devices and the analytics inside it that you can just wheel out to wherever you need to go to then understand the water quality there.
For now, still somewhere where you have power supply, yes, because it's not running on a solar panel, unfortunately.
But I guess that's a future plan.
Yes.
Making it more self-sufficient.
Yes.
Can you attach it to your bike, assuming you might have considered that in the design?
We have pictures where Heinz is just standing with his bike in front of the trailer, but unfortunately it's not yet a bicycle transportable or carryable.
So I guess you have to maybe scale it down.
Yes, but that's also then together with manufacturers.
But potential future ideas.
Yes.
Very fascinating device because it allows you to then also scale up, because if people see the need for this as well en masse, then it can be replicated. And so in a way, the concept of this first trailer can then be applied to more parts of Switzerland as well. So a lot of aspects around sampling and the dynamics of sewers, as well as what we can even search for and the practical sides that we've covered. But, where are you heading in all this? What's your end game? What's your ultimate goal and vision for the future?
I would really like to make this wastewater-based surveillance an accepted tool that is widely applied for more upcoming substances, because we hear every now and then, like, this is the opioid crisis. These are these new psychoactive substances. Can you detect them? Can we go and develop methods that are able to quantify them at lower limits of quantification? Because we not only want to have proof of it's there when we have the first cases or the first death or first whatever. And this is this transdisciplinary endeavor that I commit to and try to convince everyone on board to contribute.
Yeah. And I guess one aspect is also the more institutionalization of this practice as well, right? As far as I understand, the Swiss Parliament's been trying to push this to become more readily adopted.
Yes, this is in the context of the revision of the epidemic law, where this should be more institutionalized also during non-pandemics. And also extended to chemicals, where there is also projects from the Federal Office of the Public Health. Yeah,
it seems to be that since the end of the pandemic, many people in many countries have tried to adopt this mindset to be much more active in monitoring or surveilling the wastewater systems.
I think it's important to not stop this surveillance. I mean, it's clear that you have competing interests with tighter financial situations. And if there is no pandemic or no obvious crisis ahead, that you may want to invest in other areas.
Yeah.
But I think it's important to have a backbone running so that you have the methods up and running. You have at least a backbone of staff that is around that can maintain the expertise, and that also the logistics are on a daily basis working smoothly, so that you have a small number of wastewater treatment plants delivering samples for the pathogens in Switzerland.
Yeah.
They collect daily samples. And for the chemical side, we go on a funny 13-day rhythm.
Okay.
Because the 13-day rhythm allows you to cover each weekday per quarter once. So you have one Monday, one Tuesday, one whatever. So you cover the weekly cycles.
Interesting.
As you said, for the illicit drugs that have a recreational aspect. So you have higher concentrations and consumption on Saturday, Sunday. Mm-hmm. And then throughout the year, you can do this every quarter and you cover the seasonal aspects. Obviously, you don't get each individual special event that happen.
Yeah, that might be pushing it too far, right?
Yes, but and we're also interested mainly in the background.
Yeah.
In that it is increased at certain events, it's evident. But also there, if you ask experts, how much more is consumed at event X or Y?
Yeah.
It's very hard. With wastewater, you can say how much more was consumed.
Yeah, I guess you have to start distinguishing between different music events and music genres. I'm just thinking Montreux Jazz Festivals versus, the
there
ones in Zurich.
There is publications about these, yes.
Really?
And also in Australia.
Yes.
There is many different festivals that were investigated.
Versus, I don't know, car shows, which probably are less of a target for that. So.
And there have been many journalists asking us, can you do the World Economic Forum? Can you do this? Can you do that? But we always told them how much the baseline fluctuates and how many samples before and after you would have to take. Mm-hmm. Still, you don't know whether it's the participants or the whole entourage or whether it's tourists or whoever. And then because it exceeded the budget and the time frame they were interested in, so we never did that. Yeah. Also for ethical reasons.
Yeah, that's true. I guess, what do you see as the future for wastewater-based surveillance? Do you think the field will grow? Do you think there's been increasing interest and a lot more people are going to be getting into it? Or do you think it's still going to be, I guess, more relegated to a specialist area?
There's two answers to this. I think on the one side, because there were many more applications, many more people in science and public health domain applying this, there was also a commercial interest for companies producing extraction kits or purification kits, and also already similar to the MS2 field, thinking about automation. So you can have basically a PCR run at the wastewater treatment plant doing everything automated. Mm-hmm. This is really great, this development in this direction.
Oh, definitely.
We are still reluctant because we tried some of these methods to automate at least the process in our lab, but we always found that our manual sample preparation, the extraction, the purification and amplification was so much better with our manual work that we don't want to compromise on data quality. But we think in the future we will go towards more automation first in the laboratory, and then maybe depending on how this develops also to try to make this more mobile or on-site.
It always comes back to that quote, not trying to compromise any step in the environmental data so that the quality is always assured.
Yes.
And I heard of one term, which I believe is also being actively used, this idea of syndromic surveillance. Mm-hmm. I think you've also been quite interested in how you can use that data, or how to make sense of it.
Yes, syndromic surveillance in my late-term summary would be that you try to measure symptoms or consequences of symptoms, namely pharmaceutical consumption, in our case, from people, not knowing what drives them initially. So syndromic surveillance indeed is not direct surveillance of a disease by consulting or seeing a patient or an individual, but it's more about you observe other things, for example, absentees of pupils, and then you realize that this very well correlates with influenza or whatever. And in our case, syndromic surveillance, we observe pharmaceutical consumption at the community level, and then we try to find explanations why they use this. Let's take fexofenadine. Fexofenadine is an antihistamine. You take this against hay fever. It's a second-generation antihistamine. And so when when I say we, this is the treatment plants, and then the analysis was done by my great PhD, Stefan Baumgartner, who actually defended his PhD successfully some weeks ago.
Oh, congratulations if you're listening in, Stefan.
And so he tried to explain the fexofenadine excreted in the sewer with air pollen concentrations.
Aha, okay.
And so basically he could show almost each daily spike he could explain with the measured air pollen concentration. But then there was, in February, March, there was basically fexofenadine consumption that couldn't be explained with any of the known to be allergenic pollen.
Interesting.
And so he then took the model and used all pollen that were measured by Meteo Swiss. And then all of a sudden, one pollen from U, in German Eibe, was able to explain part of this fexofenadine consumption. Now the allergologists found, oh, that's interesting. And they now do tests to see what the allergenicity of U is, because actually in Zurich, where we took the wastewater, there is a very big U population.
Okay.
And then on the pathogen side, when we analyze for antipyretics, for painkillers, for cough suppressants, etc., all the substances, all the pharmaceuticals that are basically bought over the counter and used against any respiratory illness or influenza-like illnesses or symptoms, we use the loads observed in sewers from these over-the-counter drugs and try to explain it with the measured or known to be circulating pathogens. And when you see pharmaceutical consumption, similar to the example with the antihistamines and the pollen before, where you see consumption but no explanation for it, then you may miss out on something. And this is an indication that there is something circulating that you didn't look for, or that was not in the population you looked for.
So it's incredibly powerful because on the one hand, you're trying to find these symptoms and you're triangulating it with other data sources like the pollen reports for that consistency, for that logical deduction. And if there's inconsistency, that can actually help decision makers to detect something that you otherwise would have completely not noticed.
Yes. Whether this is severe or this is a problem that you miss it, we don't know, but it gives you an indication that it is. And these days, obviously, for this syndromic surveillance, it's more about that you do this every day. So it's about the frequency of the monitoring. More days are better. And it's sort of one time level up compared to we need to do the sampling minute-wise to get the correct 24-hour composite sample. And now it's to get as many 24-hour composite samples as possible, because it's always temporally and spatially, the more the merrier.
Yeah. Once again, the space and time challenge that we also highlighted on Lena's episode. So definitely not easy, and also quite costly as a result of it as well.
So I think for a few cities, or for one city, whether it's intraday variations or whether it's every day per year, these sentinel studies, they help to understand what the dynamics are and what you can gain, and then how to optimize costs in the future for more cities, for more sampling, or for more monitoring.
You got to start somewhere, because then once you understand better about how it works and also the technology available, that's when you can start to plan it and refine it as you go.
Yes.
So Christoph, we've, in planning this episode, I clearly decided, because it just was great, on the title Sewers, Drugs and Rock and Roll, building off the famous saying. So, as a good researcher, we always choose the titles first and then we try to fit the meaning to it, much like many model names I've worked with. But we've covered the sewers, we've covered the drugs. Are you a fan of rock and roll? I guess we've mentioned the music festivals, but what's any relation to rock and roll?
I think that comes back to high school. I was really in love with one girl. And then she asked me about going to rock and roll classes. And yes, I really love rock and roll. I really love this girl. Unfortunately, it was unrequited love. But nonetheless, this is whenever I drive by this area where these rock and roll classes took place, I have fond memories of that time. And
very sweet.
I have a couple of CDs, Bee Gees and other rock and roll. Bee Gees are rock and roll, right? I remember correctly. No,
geez,
probably not.
Probably
we'll have to. It's Beach Boys. It was Beach Boys.
Beach Boys.
Beach Boys. Yeah.
I do like Bee Gees though.
So don't say Bee Gees and rock and roll. Say Beach Boys.
It's all good. We can demonstrate our lack of understanding of the music scene here. Nevertheless, I think one other aspect, as the more we think about it, is rock and roll bands. They often involve many different parts, many different roles. You got the drummer, you got the guitarist, you got the lead singer, the bassist. In a way, it's a bit like interdisciplinary work. The music happens because everyone knows their discipline the best, and you have also one person really guiding them. And it can be a different person depending on which band you're in. And I think we've heard stories of this. I'm not going to name examples now because we've already embarrassed ourselves with our knowledge of the rock and roll bands and the genre. But in a way, you've also had that role in guiding the band because you've had to work with so many different disciplines. I guess, could you agree with that analogy? And was it something that you had to learn on the fly? Was it something you ever noticed? I mean, what's your relationship there to inter and transdisciplinary work?
I think it's mainly because I like collaboration, because I think interdisciplinary collaboration is just giving me more satisfaction than digging into a detail somewhere in one discipline. I contribute my part on environmental engineering and about the knowledge about the processes in sewers and the dynamics and everything. But I know I cannot do without the environmental chemist or environmental microbiologist. On top of that, I really like doing presentations and visualizing content such that it is suitable for non-expert audience, and also visual use of photos. Or I put a lot of time into designing slides and making good stories for presentations that can just live from the red thread or from a provoking or from a question or from whatever at the beginning, so I can do without the table of content, so that people just listen and are fascinated by what we can do with this research and then put it into context. And it's also about public relation or dealing with journalists. And so I think I often get more questions from journalists or being contacted by cities or others who want to do this because I have this role.
Yeah.
Sometimes this is nice. Sometimes it's also a little bit of a burden or extra work, but this is, as we say, in a team of 3, 4, 5, 6, 7, 10 PIs. Everyone has their part, everyone has their strengths, and as long as there is mutual respect and acknowledging everyone's expertise, this works very great.
Yeah. Oh my God, I cannot stand these slides that show the structure of a presentation. I start falling asleep when I see it, but I'm always in for a connected story. I think it's much more engaging. Any particular tips you can offer for people venturing into interdisciplinary work? What would be your biggest piece of advice there?
I mean, while there is a whole discipline, how you do this properly and how you do expert elicitation or how you do lead transdisciplinary research projects, I think it's also about giving up a little bit of your ego maybe and say, my discipline is not the most important one, but it's, as you say, it's this orchestra or this band that plays together with all the different experts. And so for me, this worked out without any formal training. I was just open and we had mutual interest and mutual respect for each other, and each discipline contributed their part. And so it worked always very well.
So with that sewers, drugs and rock and roll, we've completed the picture. And I'm happy that we did, and we came full circle there. But Christoph, it's been fascinating hearing your story, your journey. And like I do with every guest, I'd love to ask you some deeper questions so the listeners can get to learn even more about you. And innovation is a keyword there. We've seen it sort of rise through interdisciplinarity. But in your view, what does the word innovation truly mean, and how has it shaped the way you approach challenges or opportunities in your work?
I have to disappoint you with this one because I think it's really difficult to answer this question. I remember having sat in a presentation once where someone who was talking about the definition of innovation, what it is, said that most of what we do today is not innovation. We just name it this way because it's not groundbreaking or game-changing enough. It's just incremental, improving or changing direction or whatsoever. And so to not show off too much or say that I would know what innovation is or that I did innovate the field, I just don't give any answer to this, I would say.
Very interesting way of thinking about it. Actually, you got me thinking, because nowadays, when I hear that exact definition you just gave me, I think of the word disruption, which has classically a negative connotation, but is now used very widely for groundbreaking stuff.
Yeah, and maybe the mobile phone, and that it now everywhere, no matter what other infrastructure you have, everyone's got a mobile phone. Almost everyone's got a mobile phone. That may have been an innovation. But then thinking of what we do incrementally, although we are very proud of what we do and we go in a direction, and then maybe in the sum from over decades, because in the environmental sector, unfortunately, it sometimes takes decades until we reach something.
True.
I think that I would be very cautious in using innovation.
for every little thing, for fear of overselling it, I guess. And you want to be realistic. And you have always been quite realistic and careful in the work that you've done, such as the example also during the pandemic where you wanted to make sure data quality was there and not speed.
Yes, and that's also why during the pandemic we sort of failed to publish a lot of scientific papers because we served Switzerland, we served the population, and only recently we worked up all these things. And so we could advance the field still in retrospect because many have demonstrated that it works. Many have shown how well cases match wastewater or vice versa.
But in the end, I think, you saw what came out of it from really serving Switzerland. And sometimes you have to choose your path. And it feels like just listening to the story that, you really, even though you don't call it as saving lives, I think you really saved lives in the end, in one way or another, however you want to put it. Was there a key moment, event, or person that really completely changed the course of your career or your mindset?
I think you gradually grow over time, right? You're a student, you're maybe a research assistant, you do a PhD, you do a postdoc, tenure track.
The academic track, classical.
Yes, and then I think it was always a little bit more of the same, but it was really just gradually increasing. And obviously, if you compare 2 years earlier and later, there was also big differences, but it was a gradual increase. But then when I became head of department, it was really a big jump because all of a sudden you're responsible for many more people, also people that you don't directly collaborate with. And even if they are all doing very independent research and you don't really have to look after them, I had to try to avoid micromanagement and taking care of everything because I really care for people. But it was a moment where I realized now it's different.
Yeah, I guess it's a big moment taking on that responsibility. Head of the Urban Water Maangement Department at ERWAG, which you've been in that role for
3 years, yes.
Yeah, incredible. And I guess, with that, how do you stop yourself from trying to micromanage or trying to feel disappointed that you can't do more and you have to let people move along?
Yes, I also learned this in general in life, not only at work in science. I mean, you cannot change people.
No.
You can try to influence them. You can try to go ahead as a good example or be a role model. But at the end of the day, everyone has to deal with it herself.
Yeah, everything's a learning curve in life. Also, once you've gotten to a stage where you're now responsible for people, that in itself is a learning curve from the sounds of it.
Yes.
What tips and strategies can you offer in terms of time management? Surely you've now refined your time management after becoming head of department, but how do you maintain a balance between your professional and personal time?
Have a lot of friends who ask you to go and come for sports so that you have to do it, not finding excuses, not relying on your self-discipline.
That's handy.
I think that's one of the nicest things, yes. Then obviously I have a family with 3 lovely kids and a wife, and we have animals, a horse and a dog, and that also takes time, although it's my wife who looks after them mostly. But it's this, on the one hand, it fills your day, and we try to not have full agendas, to have flexibility and freedom to decide on the spur of the moment. But I think it's just remain active and do what you like doing. And sports for me is always a good divertimento, whatever this is called in English.
Distraction.
Because then you focus on other things. Or you have good ideas. If you don't try to focus and find an idea or find an answer, all of a sudden you get, that's great idea. Yes.
No, incredible. But I guess, you set up the environment such that you have to. I mean, I feel like every time I see you when I come to visit you in your office, it looks like you're in biking gear or at least outdoor gear, ready to go hiking or cycling at the moment's notice. This is
the freedom that I don't have sort of these customer relationships. I'm not, I don't have customers, or the customers are at ERWAG colleagues that are also outdoor people. And that's true. Which brings me to another aspect where you said, how do you do this? I think we're very flexible when we do our work, which is on the one hand great, because you can do it whenever you want. No one controls really when you are at work. But it's also the danger because you can do it always, anywhere. Like whether it's home office, whether it's evening, whether it's whatever. You send emails out at 2 a.m. or whatever, which may not be a good signal to PhD students, but you have to work when you are productive. And on the other hand, I also take a day off or half a day off during the week when it's nice weather or when you think you've achieve what you wanted, because that's the other thing. We're never done with work.
No, you're never done.
We're never done. You always have ideas. You always have more to do. There is always someone waiting for some response.
But giving yourself the time to then separate from work also helps the work at the end of the day, because you're more energized, you're more refreshed. The ideas come to you, as you said. So, no, incredible advice. What is your favorite childhood memory?
Well, maybe climbing the highest peak in Switzerland, almost 15,000 feet high, so 4,500 meters. Although I did this as a teenager, maybe this is not counting as a childhood experience anymore.
No, we can make it count.
But if it's really childhood, I think it was when I could accompany my father. He had to give a signature in Paris in his position as a CFO, and he took me with the airplane to Paris, and it was my first time flying just for one day, Paris and back.
Oh, wow.
And I think that was really amazing. And we climbed the Eiffel Tower. No, we went up. We didn't climb it.
You took the lift.
we went up to Eiffel Tower, and I got a small key ring. Yeah. And that was really memorable.
Christoph, I almost believed you that you climbed the tower. I mean, given your outdoor gear, but hey. And you also preceded that with the story of the highest peak in Switzerland. So hey, you could have said nothing, and I would have believed you. No, incredible. I guess first time experiences are always very magical as a child, because your mind is open, you're open to wonders. And I guess, on the other side of it, life experience is also what teaches you, and especially challenging situations. So what was the most challenging situations, or one of the most, that you've ever faced in your career to date, and how did you overcome it?
I really care for people and the well-being of the people, and that they can perform at their best level, may it be at home, my children, or at work. And when there is tension between people, I try to relieve the situation, or I try to help in this situation. But I often struggle. I listen to the one person, I say, you're right. I listen to the other person, I say, you're right, but I cannot sort of resolve it. And so I suffer then with the people involved. And this happens every now and then at different levels. And if it's getting more severe, I realize I just need external help with people who know how the system works, but who are experts in coaching and dealing with difficult situations. And this is how I dealt with it.
Yeah. I guess as someone who's now head of departments, do you also still have strong contacts to mentors, as you said, coaches, of people that you used to work with or have known in the past or worked under?
I think that's the question, or that's the answer to the next question.
Oh, already. Oh, well, there we go. I'm foreshadowing, so I'll just throw in the next question and we can make this one full conversation. But I guess that also relates to what advice you can offer to young researchers starting out.
I think it's about having a good hand in choosing a good institution, good supervisor, good mentor, so that you can try to realize your dreams or help contribute to make it a better world through science, through what we do, through any other discipline that helps improving our lives. And I was always in the lucky position that retrospectively I found out this was a good decision, or someone else made this decision, or someone else introduced me to a network. But at the end of the day, that's just creating opportunities. I think everyone has to die Gelegenheit am Schopf packen, so to realize these opportunities, him or herself, and contribute their part. And it's not become easier. I think everyone who is at a certain stage in their career, they know it takes a lot of stamina, a lot of endurance, a lot of perseverance.
No, that is very true. A lot of grit and trying to, I guess, sit it out, challenging situations.
And so all you can do is do good searches or research on what institutions, which individual supervisors may be a good match with your personality, where you can perform at your best.
And I guess you once told me a very nice German proverb, steht der Tropfen hüllt den Stein, or in English, constant dripping wears away the stone. And I think that's a very well-suited proverb here. It's to, I guess, keep going, small steps, one by one, and it will slowly amount to something.
Yes.
Particularly also in interdisciplinary research where, the dynamics are even more challenging as well. But yeah, very, very solid advice. And I think something that everyone can always take on board. And so as we near the end of this episode, what would you most like to be remembered for?
At home, I'm probably remembered as the bad cop.
Yeah.
So I'd prefer to be remembered as the good cop or maybe not as a cop at all. But as I said before, I really care for people. Even maybe my open and direct nature sometimes masks or overcasts my inner drive for really caring about the people, because I think I also suffer from some childish sense for justice and that I think I know what's right or wrong. But in my heart, I really care for the people and their well-being, and I care for the environment. And if I'm remembered for striving for this, and maybe it's just sometimes not very well communicated, then that's what I would be very proud about.
It's beautiful. And thanks for that. So where can people find you if they want to get in touch?
Well, as long as I work at EAWAG, I think it's easy to find me on the website.
Are you on LinkedIn, social media?
Yes, I am, but I don't really use it. So I think it's best to contact me personally.
Sure. We'll put definitely links to that, your profile on the website. And I guess if anyone's in Dübendorf, I guess they can go look for you.
Yes, sure.
Easy to find. Just look for someone with outdoor gear. But no, we'll put this as well as a lot of other of the beautiful information and wisdom that we've discussed on today's show in the show notes, so that listeners can definitely look up some of this material and learn a lot more. But Christoph, thank you so much for coming onto the show today, for sharing your experience and really just showing us a beautiful example of where interdisciplinary research and interdisciplinary thinking can lead to really big outcomes. Like I do with every guest, I always give my guests the final word. So one last message for the listeners to take away from today's show.
Except that I thank you for your enthusiasm for doing this and giving us the opportunity and making this fantastic collection. I hope you enjoyed the show.
Thank you very much. And that wraps up our incredible, fascinating and eye-opening episode with Christoph Ort. For more information on emerging pollen allergies, a guide on climbing the Eiffel Tower, details on famous rock bands, or just a collection of epidemiological studies, check out the show notes for more information over at peterandbach.com/podcast. And as always, thank you listeners for tuning into this episode and for your feedback and support. If you are enjoying the show, I would be incredibly grateful if you could share this podcast with your family, friends, colleagues, and even fellow bike riders. Subscribe or follow this podcast on Spotify, Apple Music, other podcast channels, or follow the LinkedIn group to stay up to date with the latest releases. If you're curious about me or my work in general, you can also check out my website or social media. Head to peterandbach.com, my YouTube channel Peter Marcus Bach, that's Marcus with a C, or follow me on X at Peter and Bach or Instagram at peterandbach87. Feel free to reach out to me with any feedback or guest suggestions so that I can keep improving this show. The podcast's intro and outro song is called Starsky by Alex Kieran. Stay tuned for our next episode and next guest to hear how they are tackling the grand challenges.